All right. So today the plan is mostly to work on problems. These pages from the notes are on Canvas, but first I want to just talk about the induction proof from the homework. And so I have the homework ready to give back to you. Most of you did really well. On the homework 6, each problem was worth 2 points. And so those first two problems I was kind of strict on. Of did you have, so some of the things I saw were like you wrote them in like a list format of itemized or enumerated, whereas I tend to prefer, and like when you go and write a math paper, you don't write like one, we did this, two, we did that. You can use that, but it's very sparingly. Like when there is an actual situation where something needs to be enumerated, then that's acceptable. But in general, proofs tend to flow more like paragraphs, like, right? Like we're writing this story, even if it's maybe not an especially thrilling story of saying that X plus Y has to be irrational, it's still a story that we're trying to tell. And so I wanted to talk specifically about the induction proof. And so let's go over here. And so I have, let's try and zoom out on this a little bit. Yeah. Okay. So I want to prove the statement P of n for 1 plus 2 plus 4 plus some power of 2 is equal to 2 to the n plus 1 minus 1 for every n greater than or equal to 1. And so I'm going to begin my proof. And I'll move this aside. So let me just get some thoughts down on paper. So I'm doing the base case, which is going to be n equals 1. And so that's 2 to the 1 is equal to 2, which is equal to 2 to the, and then what's the right-hand side? 1 plus 1 minus 1, which is 2 to the 2 is 4, minus 1 is 3. That's not correct. I need a 1 there. And so if we go with that, like, that's correct. Like, that is the base case. But the thing is, now we need to flesh it out a little bit and tell the story about it. And so I would not recommend starting with base case. And I would recommend instead starting either something like we prove this by induction, and then we can say for the base case, and then we can say if I want to specify what n is for this situation, I can say n equals 1. So, and then maybe let's say, have the right-hand side. So 1 plus 2 to the 1 is equal to 3. And maybe if I do want to specify that I've just been doing this on the left-hand side, maybe I can say on the left-hand side. And then I can give the right-hand side. And so that's 2 to the 1 plus 1 minus 1 is equal to, so here's a matter of interpretation. Either you could say 2 to the 2 minus 1 and then 3. For me personally, I think this feels a bit overkill because like I can do 2 to the 1 plus 1 minus 1 in my head. And so we can delete that and just say that this number is 3. Right? That's simple enough math that I don't need you to spell out every step. And so if I said, so I could leave a period, but then that's kind of forgetting. I've said on the left-hand side for left-hand side, and so I probably also want to say for the right-hand side. And then that's the way that I've spelled out this concise equation. So I don't need that anymore. Let's see how that looks. We proved this by induction. For the base case, n equals 1. So, and this is maybe a matter of preference. We could maybe move on the left-hand side before. Maybe that's more clear. But I think it's okay. And 2 so 1 plus 1 equals 3 on the right-hand side. Great. So we've written the base case in paragraph form. So now it's time for the induction hypothesis. So we could say for the induction hypothesis, we could say that. Or since we said we're proving this by induction, we could also just skip over it and say, so this has to be in math mode. We assume P of K, which is 1 plus 2 plus 4 plus dots plus 2 to the K is equal to 2 to the K plus 1 minus 1. So I was about to say for n equals K, but if I'm saying P of K, I don't think I really need that. So let's see how that looks. So we assume this, and it kind of feels like we cut it off, but this is actually a sentence. So we assume P of K, which is left-hand side of the equal sign, equals right-hand side. So we assume something equals something. That's a sentence. And so some of you had, we now show or prove P to the K plus 1. That's fine. One of the things that I marked some of you down on was you went immediately from here to, okay, let's show P to the K plus 1 and work out how that equals P to the K plus 1. And that's not correct because we have to start with P of K and then work our way to P of K plus 1, right? We can't assume what we're trying to prove. We can state, here's P to the K plus 1. That's what we're going for. But we can't start there. So, the solution here is to add 2 to the K plus 1 to both sides and then work out on the right-hand side of P of K. So we add 2 to the K plus 1. Nope, that's still in math mode. And then since I just mentioned P of K plus 1, I think it might be useful to mention P of K here to say, I'm not adding 2 to the K plus 1 on both sides of P to the K plus 1, right? I'm adding it to that. So just to be clear of where that operation is happening. And so let's, have I showed you a line yet? I don't know if I have. A line is an environment that is really useful to show for like, if you have a list of equations that you're going to have, a line is useful to make it all line up nicely. And so I'm going to take that And in the align environment, you can set where that alignment happens. And so typically when we're writing equations, we want to make it at the equal sign. So the equal signs will always line up. So we can say and equals, and then I need a 2 to the a plus 1 over here. And then I'll copy the right-hand side plus 2 to the k plus 1. So we can do that. So we get that. Let's see what it looks like. We now show p to the k plus 1. Adding 2 to the k plus 1 on both sides of p to the k, we see this. And so here's where like it starts to get into personal preference. Either you can say we're doing algebra to combine like in between this step and the next step, or maybe you can just show the next step. I think this is simple enough math that you can just show the next step. So I need a new line, and then I don't need to type out the left-hand side of the equal sign because that's not changing. So I can just do and equals. And then what happens here? So like we move the 2 to the k plus 1 next to the 2 to the k plus 1. Then we factor out a 2. And so we don't need to show all of those steps. So maybe we show 2 times 2 to the k plus 1. Minus 1. And then this is, so the 2 on the outside has a exponent of 1. So 1 plus k plus 1 is 2 to the k plus 2. That should be a 2 minus 1. And then I'm going to end it with, like, I could say like as desired, or I could say which is the form of p to of k plus 1. And so now we're done. We've done the hard part. And so now we just need a sentence to say, here's what we did. So we could say the statement holds, or you could have something more of like, since we've proven the base case and that p of k leads to k plus 1, we've proven this by induction. So I just need something of like, therefore we did it, instead of just, we're done. Like, we want to kind of gently conclude. And so, okay, so this still, like, it maybe feels like a lot of math. And so we can add, like, adding on both sides and simplifying, we could say, and that maybe helps that flow a little better. Of, I'm going to do this and then simplify. Here it is. How's that? Is that clear? Any questions? So this is where proofwriting like is kind of an art, right? And it takes practice to develop this intuition of I'm writing this sentence. Oh, I need more words here. Oh, I need to describe it a little bit more here. That's just something that takes practice. All right. So for the rest of the class, that's not where I can't scroll on there. I can scroll on here. So the rest of the class I have, so the measure problem from last time, the computer problem. And then several problems from the homework. So some that we haven't done in a while. So maybe let's try and do those. I want to make sure we talk about this one, the at most 2 Republicans, at least 3 Democrats, because that one's tricky. And then basketball question. So on Canvas, I have, oh, too far, October 15th activities, and that's just the pages from that. So you can pull that up. I'll also show them up on the screen. And so I'll stop recording and we'll split into groups, and that'll be our day.